All right, 3.7. Can you hear me?
What?
Is this loud? Can you hear me?
What?
3.7. Can you hear me?
What?
3.7.
Ah, I like your volume.
Well, volume is a measure of how much space an object occupies, or how much you could actually fit inside of that object. So as volume is a 3D concept, our units are also going to be cubic, right? So to the power of 3. On your formula sheet, you have some general formulas for volume. What we are going to start off by doing is taking those general formulas and making them more specific for different shapes. So first of all, we're going to sketch a rectangular prism. Oops. There we go. And determine a general formula for its volume based on the length, width, and height. Because volume is a prism, it has 2 bases there. Our general prism formula would be the area of the base. Remember, we're still seeing that same variable, or that capital B, like we did in surface area, represents the same thing, times its height. Well, taking a look at my base is a rectangle. So I could say the area of the base was just length times its width. So its volume could then be represented as length times width times height. And that's it. That's a rectangular prism's more specific volume formula.
We can similarly look at the volume of a cylinder. As we've stated previously with surface area, a cylinder is kind of like a circular prism. It's technically not a prism because prisms only have straight edge sides, and a cylinder's got a circle base. But we can kind of think of it that way. I've done better lines before in my life. Ooh. Close enough. So there's our cylinder, and it's still got a base there and at the top. And that thing has a height, and it's also got a radius. Now, because it's just like a prism, we can still say that its volume is the area of the base being multiplied by the height. And in this case, this base is a circle, which has area pi r squared. When we then stick that in over for this base, we can say that the volume is pi r squared, replacing the base, times height. So it provides us a direct way to get the volume of the cylinder based on that height and radius.
Taking a look at this next one, we have a rectangular based pyramid, and we want to figure out a more specific volume formula. Well, rectangular base pyramids are not regular pyramids because they don't have a regular base. Remember that we talked about regular being a base that has equal length sides with equal angles. And this rectangle, although its base will have equal angles, its side lengths are not going to be same. So if this were surface area, we wouldn't be able to use those general formulas. However, for volume, it could actually still get away with using those general formulas. It still applies. So for a volume of a rectangular based pyramid, we would use the general formula. Volume is equal to 1/3 the area of the base times its height. All right. So taking a look at this base is a rectangle. It has a length, a width, and we know that the pyramid as a whole has a height. Well, the base itself can be represented, or the area of the base can be represented by the formula length times width. So if we wanted to replace that uppercase B, that area of the base, we could replace it with length times width. And of course, we still have height. So this would be a more specific formula for volume of a rectangular-based pyramid.
And once again, similarly, we can look at a cone just like that. A cone is like a pyramid with a circular base. Now for this, don't be too surprised or shocked or scared, but I'm going to switch to our less often used lavender. It is a beautiful color and we respect it.
Just kidding, you told me not to be scared.
Yeah, be less scared. Oh, that's not where I wanted the dotted line.
That's what's really scary.
What's scary is my impressive dotted line skills right there. You see that?
Dang, frightening.
I thought you'd react with a scared sound again.
Sorry, we'll rehearse better next time.
No, I legitimately thought it would scare you. Man, we need a cricket sound to just play. Anyways, there's my cone. And the volume of this pointy-topped figure is still 1/3 area of the base times the height. And when we look at this thing, it's got this base that has an area. That's a circle, so pi r squared. Therefore, we can replace this b with a pi r squared. So that's all we change line by line. The volume, this 1/3 stays the same, this h stays the same, but that b turns into pi r squared. So that's where a more specific formula comes from.
So hopefully you feel pretty comfortable with replacing that capital B, the area of the base, with these more specific formulas after going through those surface area sections.
I do, yes, thank you.
But just in case you were curious or you wanted to figure out the more specific formula for any of our shapes, you could do so and you would come up with these. Of course, you are only going to be provided with the general ones, so for any prism or any pyramid, because volume, we also include rectangular or irregular shaped pyramids. That's totally cool. And then you'll also get the volume for a sphere. Those other ones you will be able to get based on deriving them from our general formulas. Aight. So now we are going to look at more specific examples and we're just going to start calculating volumes. Here we're going to make sure that we provide the exact value as well as the approximate numerical value to one decimal place if they differ. So for starters, we will start off with the cylinder with a radius of 2 inches and a height of 5 inches. Now, I know that a cylinder is treated just like a prism, so its volume will be the area of the base times height. I know that my base here is a circle, and the area of a circle would be pi r squared. So I have pi r squared times height. I know in this case my radius is 2, and my height is 5. So I get pi times 2 squared, which is 4, times 5, which will give me 20 pi. Now, what are my units? Here I had inches, and since volume is a 3-dimensional concept, our units are going to be cubed, so we're going to have 20 pi inches cubed. And this here is my exact volume. Of course, the question also asks us to represent our approximate volume as well. So, I don't know. Approximate volume. That would be as if we go ahead and plug in 20 times pi using that pi button into one decimal place. We get 62.8, and again, cubic inches. Be sure that you're not forgetting our units, especially when we have pi. For whatever reason, people forget to include those units because they're like, I have pi, that's something that's not a number. But it is.
I'm going to draw myself a cone that has a radius of 12 inches and a height of 10 inches. Not to scale, but I'm just going to give myself an idea as to what's going on. My pro tip for you, that would actually be a way wider cone if I do it. But my pro tip to you is to try these other examples now that you've seen a little bit. See what you can do if you're feeling it. If you're not feeling it, that's okay, you can wait a little bit. But we encourage you to try all the things and see what you can do. La 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 la. Yeah, dotted line skills, though.
We'll see better.
Are you serious right now?
Oh, sorry. Yes, I'm very supportive of
Yes, I'm not allowed to be frivolous.
Thank you, Siri. That was very handy. R equals 12 inches. And this height, actually I don't need to write it. Oh, it's too late. I'm doing it. And this height is equal to 10 inches. And then we'll do all the things. Volume is equal to 1/3 area of the base times height, which in this case is 1/3 of pi r squared times h. And then we just substitute in everything we know. 1/3 times pi, radius is 12 squared, and then height is 10. And when I multiply things together, don't forget, like, you can use a calculator for the step of what's 1/3 times 12 squared times 10. That is acceptable. But however you get there, whether you process it manually or not, you should be getting 480 pi. Oh, I got my units in there. Psych! No, I didn't. I need to put those in. And this will be cubic inches. Of course, you will note that what I've got there is my exact volume. If you want my approximate volume, well, that's going to be over here in my writing right there.
It looks like plagiarism to me. Anywho, please.
Yeah, 480 times pi is something in the neighborhood of 1508.0 inches cubed.
Moving right along. So now we have a sphere, right? And we haven't seen a sphere yet, but we're about to, because I'm about to draw one. Actually, there you go.
Oh, dang.
Yeah, I'm talented. Not a big deal. Not that talented. I'm more about the dashed lines than the dotted. Oh, that's too thick. Close enough. And this sphere here, that rhymed, has a radius of 9... What? 9 meters. So here we are, and we have a specific volume formula just for the sphere, and here we have it. Our volume is 4/3 pi r cubed. Now, common mistake, people are like, I never used cubed before, so why would I use it now? I'm just going to square it by accident/purpose. Don't do that, you're not going to get the right answer.
Yeah, oh goodness.
Here, we don't have to change anything because it's already specific to a sphere, so instead of r, I'm going to put 9, and then we have that cubed. In your calculator, to plug that in, you might see the button that looks like this. That implies to the power of. So if I wanted to do 9 cubed, I'd hit the 9 button. Then I'd hit this little upwards hat to the power of. And then I'd hit the 3 button. And that should get me 9 cubed.
You might also see like the little XY button, and it might look like something like this. So that might also be your exponent button if you don't specifically have a power of 3 button in there.
All right, and when you plug in these values, so 9 cubed times 4/3, we end up with 972, and then of course we still have our pi. And now our units, we're meters, so we need to still have meters cubed up in there. And in my own writing, I'm going to write exact volume, and I could actually still determine the approximate volume as well. And that approximate volume, when I plug that in using my pi button, would be 3,053.6 cubic meters.
Even if it's your own writing, isn't it still technically plagiarism to copy your own work?
I didn't say. I don't think so. I don't know. Gosh, where's Miss Gasick when you need her?
I'll call her later. I'm going to draw myself a rectangular prism because they're great. This one will have a 3 by 4 centimeter base. Good enough. No, it's not good enough. I can do better. Empires have fallen on the principle of good enough. Maybe. I don't know. I've never heard of any. Any case. I've got a 3 centimeter by 4 centimeter base. Oh gosh, does 3 go here and 4 go there? Maybe it's the other way around. Doesn't matter. I can just tilt this box on its side. It's still going to hold the same amount of Lego. So I'll just call this 4 centimeters. This can be 3 centimeters. And its height here will be 7 centimeters. And then I will get its volume, which is base times height. The base is length times width. The height is h still. And subbing in all the things, I've got 3 times 4 times 7. And according to my sick math skills, that gives us 84. I'm not putting a pi in here. There's no pi in this formula anywhere to begin with. There's not going to be a pi here either. But I do still need my units. In this case, cubic centimeters.
And that's your exact and approximate volume, I suppose. They're the same.
Truth.
All right. Last but not least, we've got a rectangular base pyramid. And remember that we said even though this is not a regular pyramid, it can still follow under that same volume general formula. So here we go. We have 3 centimeters and then 4 centimeters over yonder. Oh, and look, it also has a height of 7. This is same as this guy. It's like the pyramid version of the one here. Now, something kind of cool that we might notice is the volume formula is 1/3 the area of the base times height. So if this volume is the area of the base times height, its area of the base is the same because they're the same measurements, and the height is the same because, again, same measurements. The volume of this pyramid is going to be 1/3 the volume of its corresponding prism. And this actually happens to be true for any prism and pyramid with the same base as well as the same height, because we can see why in the formula. So, I mean, I could go ahead and just see, well, let's just take my 84 and divide by 3 or times it by 1/3. I'll get the same thing. But just for the sake of this, let's plug it in and be 100% sure. So my area of the base I can calculate by saying, well, it's a rectangle, so length times width. I still have height. And my length is 3, my width is 4, my height is 7. And again, you could see that we're going to end up with an answer that is 1/3 the size of the one above, which happens to be 28 cubic centimeters. So that's kind of cool. If we have any prism and corresponding pyramid, we can see that relation without having to do those more precise calculations.
Yeah,
So
that's pretty neat.
it's kind of dope.
Fairly,
Anywho,
yeah.
we have some textbook practice.
Woo!
And now you officially have that textbook practice.
Oh, I wish I still had it.
Maybe they'll give it back when they're done.
Okay.
Anywho, check it out, and we will see you
In the future.
future.
Future. Beep boop. I'm a robot.